Okay, hello and welcome to this very exciting compositing tutorial from cgtextplus.com. I'm Hugo Trump and, welcome again. So I made this little picture of the tutorial, what we are going to do. The tutorial is divided into 3 days. Obviously, we're going to start off with an introduction to compositing. What is compositing and what things exactly get involved in the process of creating the perfect integration. Second, I will talk to the approach to a visual effects shot. What departments of the film industry are involved, and how does it work? The practical things. Then the third thing we're going to talk about is motion tracking, which is pretty much the key to the perfect integration, but more about that later. Then in day 2, we are going to use the motion tracking data, and we'll go ahead in Maya and we'll start using a very basic model. We'll start trying to integrate that object into our shot using lighting techniques and rendering techniques. And then in the third day, we're going to composite everything in Nuke, and that is going to be a quite exciting day because a lot of nice techniques like image projection and more are being shown by me. Yeah, that was pretty much it, I guess. So, the introduction to compositing. What the heck is compositing? Well, I kind of looked it up to find an official sentences for it, an official term, but I couldn't really find anything. But I think the thing that describes it the most is integrating computer-generated images with real-life shots. What compositing is on set we are shooting a shot, obviously, of a scene. Then what we do is we take the scene to the computer, then we make something with the computer-generated images, which is mainly a 3D model, a matte painting, or whatever. And then we are going to integrate that to make the final shot. So compositing is the process of integrating those CG images with the final shot. And it is probably the most vast and the most extensive industry in the film kind of world. There's just so much which has to be done for the final integration, and well, I'll show you a little bit of that. At least I will try. Then, the general approach to visual effects is visual effects should extend a video and not replace it. There's a few things why people want to get involved with computer-generated images when they make a film. First of all, when things are too dangerous or too expensive to do in real life, then obviously the computer has to come in and it needs to be recreated in 3D. However, a lot of things need to be shot real, like things like rain, and other atmospheric effects sometimes just can't be replaced, because every drop on someone's head or every drop on, I don't know, some kind of surface, you just can't recreate that. So obviously directors are trying to shoot as much as they can in real life, but when they have to create really extensive shots, that's where CG comes in for like matte paintings and CG creatures, things like that. But you have to find a balance between how much between the amount of CG you want to use and the amount of real life, because obviously when you do not have the ability to use CG in your film, that kind of reduces the options. It kind of limits your creativity. But when you use too much, it becomes too expensive and the whole process is just going too slow. So you need to find a good balance between the amount of CG and the amount of real-life stuff. So obviously what people start with is a storyboard, in which the idea of all the shots is being drawn. then together with the art department, the visual effects department, and the director come together and they discuss, look, this is what we want, can this be done, and can this be done for a reasonable budget and within a reasonable time. Well, that well, of course they have a discussion then, and when that is done, what they do is they prepare everything and stuff, and then they shoot on the set. So now the pretty much most important part comes. After the visual effects department has received the footage which was shot on the set, they have to integrate the CG. So this is a very, very difficult and almost scientific process. It is called motion tracking. And after the motion tracking, the visual effects are added and everything is created into a final shot. But for now, we are going to focus on the departments. So, pretty nice picture, I think. On the left hand, right here, what we can see is, well, this is supposed to be the director. I just found this image on the internet, so whatever. Anyway, this is the people discussing the storyboard and the visual effects and stuff. So when that is done, they are shooting in real life, everything is shot, and then the departments come in of the visual effects company. First of all, with this nice number 1, we have the modeling department. So it goes from here to here, not actually from here to 6, but I just really couldn't figure that out. Anyway, first it goes to the modeling department, because obviously when you want to integrate a CG thing, you need to have that CG thing. So the modeling department is a quite extensive department where obviously hard surface models like cars and I don't know, all sorts of things are created, but also polygonal models and creatures. And then it goes to the second department, which is the texturing department, which is also a really important department, because that is where the models are getting textured. And obviously, when you want to have something integrated into a real-life scene, you need to work with really high-resolution textures, and you kind of need to match them up with the environment. The texturing department is a pretty fun department. Yeah, it's quite nice. Then we are going to the animation department, and this is along with the compositing department probably the most extensive, the vastest department in the CG industry. The animation department, just so many things get involved, including motion tracking and motion capture, and of course keyframe animation, facial animation, character animation. There's just a lot of things going on. So when we have our texture model animated, we need to go to the fourth department, which is the lighting department. So in small businesses, usually the fourth, the fifth, and the sixth department are kind of going together, they merge. So this is the lighting department, obviously. This is where it gets kind of tricky, because compositing is matching up a CG image with a real-life image. But if you want to do that, you also have to light it like the real-life scene. So that goes with HDRI images and stuff. So obviously those three, this is the rendering department. Those three are really closely connected. So anyway, when the animated and textured model is being animated, is being lighted according to the light of the scene, then it is being rendered, and that is also a very important step. So you can see here a calculation of some kind of vague formula, I don't know. Rendering is the most scientific part of the industry, and it involves just so much knowledge, and it also involves a lot of accuracy. And it is often kind of related to the compositing thing, because when you're dealing with things like subsurface scattering and stuff, you know, that's obviously integration. So these three departments are pretty closely connected to each other. because the sixth department is the compositing department, where all of the work of the first 5 departments is coming together and integrated with the real-life shot. So that's kind of the general approach to visual effects. That's how the most major studios like Digital Domain and ILM work. Okay, so the final picture is about motion tracking, and its subtitle says the key to the final integration, which it really is. So you've probably already heard about motion tracking, what it is. If not, this is a sentence from Wikipedia which I found. It says, in cinematography, match moving is a visual effects technique that allows the insertion of computer graphics into live action footage with correct position, scale, orientation, and motion related to the photographed objects in the shot. It encompasses extracting motion information from a motion picture, particularly camera movement. And that last thing is what we are going to be focusing on, extracting a camera movement from a real-life scene. So in fact, it's not that hard. Let me just explain the principles of motion tracking. Let's imagine that we have a camera on set, and it's on a tripod. And it's panning to the right, so the camera is moving from left to right, the lens, I'm sorry. Then, obviously, the shot is getting imported in the computer, and then in a motion tracking software, a button which says run is hit, and then the computer is calculating points in the scene. So, what you have is a scene, and in the scene there are recognition points. So this is really important. If you have, like, for example, a green screen and you're panning on that green screen and you want the computer to be able to extract the motion from that pan, it is impossible because everything is green. The computer needs to have recognition points in order to create the motion tracking shot. And what it does is it recreates the camera movement of the camera on set, but then in a virtual environment, so that when the final compositing comes in, what you can do is you can take your model, then place it into a scene which has the exact same lighting environment and stuff like the real environment, and then the camera of the computer, the virtual camera, and the real camera are matching up. So therefore it is quite important to know how exactly do I prepare footage for motion tracking. What shot can be motion tracked and what shot can't. So a lot of big studios, they have a special motion tracking department where also a lot of manual motion tracking is being done, because in some shots some shots are just so blurry, or they go so fast, or they don't have enough recognition points for the computer to calculate it, and that is where the manual motion tracking comes in. So right now we'll head to After Effects, where I will show you how to prepare your footage for motion tracking and what exactly gets involved. Okay, so here we are in After Effects, and I've loaded my footage, which is called finalfootage.av, and this is the footage. Okay, so there is obviously a few major problems that we have to try to tackle in order to get a clean track. First of all, the lens distortion. You can see it pretty much right here. You can see that these lines are kind of bent, and that is because of the focal length of the camera, which has a very short focal length. These lines should be straight in order for a clean track, because lens distortion can severely influence your track on a bad way. So that is the first problem, the lens distortion, the fact that the lines which need to be straight are not straight. Then the second problem is, as I zoom in, I can see that the focus isn't right we are not having sharp edges at all. So a motion tracking program needs recognition points, and when they are not sharp, the tracking is based on RGB values, so basically on color. But you can see here that we have a kind of transition between the black and the white here. So the more defocused something is, the more difficult it will be for the tracker to track it. So it's a quite basic shot. We're kind of dollying towards the window, and then we're just having a normal pan shot. So let's just drop this into a new comp and drop this into the comp folder. I'd like to keep things organized because otherwise things get so messy. Okay, so what do we need to do to prepare the footage for motion tracking? Well, first of all, we want to sharpen the image. So you might think, sharpen, why does it help? You can't focus something which is defocused by just applying a sharpen filter. No, that is true. But you can see that as we set this to probably 20, you can see that we are certainly having some improvement here. And that is really because of the sharpen filter. Let's just set this to 0 again. So you can see that these edges right here are pretty vague and they kind of blend together. And as I set it to 20, the colors are getting deeper and we're having much sharper edge. I mean, it's pretty obvious why this is helping the tracker, because the tracking software is tracking the shot based on RGB values. So each of these pixels contains RGB data, which you can also see right here. So as I sharpen the pixels, or at least as I sharpen them, you can see that the color become more intense and they become more contrast, because as I set them to 0, you can see we are having kind of more blendy, kind of vague image. So it really is helping. Yeah, so that's the first thing we can do. Second thing is color correction. So let's just apply a curves filter. Okay, so this is also pretty easy. When we have this area, for example, what we can do is we can just drag the black to white right there, and we can just use this one to make the white even more white. So what we're basically doing is we're adding contrast, and just so that this is not obviously a good color correction for the final shot, as it should be exported. This is purely for the motion tracking, so it doesn't matter how your shot looks. It just matters how the data is being exported for the motion tracking software. So the reason that I made the darker color lighter is because sometimes when you have a really dark area like here, you can't really see the details here. And as I do this, well, this shot is not really a good example, but for example, when you're shooting in a kind of dark environment, lighting up the scene kind of really helps, because you get more recognition points for the tracking software. And that's pretty much it. There's obviously other things that you can do, like where is that? I'm sorry, select the footage first, then noise, where it is. Is it no noise and grain? There it is. And then we want to remove the grain. That is obviously also a thing that you can do. And that is also, here's a quite good example, because as you can see, this air contains quite grainy. The camera is quite grainy, and sometimes the tracker sees these things as recognition points, and it clearly distorts the data of the image. So you can see that in this preview region here, we are having way less of these points. I don't know if you can really see it. Let's see if it passes to 5, maybe. Yeah, now it's a little bit better. So that's things like removing noise and grain also obviously helps. You just want to get a clear, focused image for the tracker, and then things should be fine. Another important thing, but which you can do in the software, by the way, which you have to do on set, is to make sure that you have recognition points. Right here, if I would pan up now, and I would see only the sky, then the complete track would, just be a disaster, because the tracker software wouldn't be able to recognize any of the points of the houses like here. So it just won't be able to generate a virtual camera move. That's quite simple. So that was pretty much it in After Effects. Let's just now export this shot and go into Buju, where we will actually perform the motion tracking, which is quite exciting. Okay, here we are in Buju. So let me just explain a little bit about Buju. When Buju was first introduced, a couple of years ago, well, actually pretty much years ago. Anyway, when it was introduced, along the motion trackers, people began to start to say, "Can you track that for me?" "Oh yeah, we'll Buju it." Because Buju was a revolutionary program in the motion tracking world, and it has therefore been used in many great films like Harry Potter, The Lord of the Rings, and movies like that, in a lot of feature films. And it offers amazing quality, and it is just so extensive. The license is obviously not mine, because I work for this visual effects company in the Netherlands, and they owe a Buju license. One license is like $10,000, so obviously I wouldn't be able to buy the license. But anyway, my visual effects company where I work for did, so now I am able to track shots with Buju, which is quite exciting. Although it's not my department. Well, anyway, I have imported the footage into Buju, and as I hit the play button, you can see the green area here is the kind of rendered area, like in After Effects. As I play this back, you can see that it just plays back. So I've optimized the footage for the motion tracking, and everything should be fine now. However, before we even start to do things, what we need to do is go to Edit Camera, and we'll need to just make some things clear. We're having an HD 1280 by 720 camera, so that is quite good. Also here the pixel aspect is right, the inches they're all pretty much good, except for the frame rate. As you may have noticed in After Effects right here somewhere, it said that we had a frame rate of 30 frames per second. So before tracking, we need to do that. And then what we can do is go into the Track Features menu, which opens this window, and we can just click Advanced. So this is pretty much where it all starts. And we're having some parameters here like sensitivity, and as I increase it, you can see that more points are being generated, and as I decrease it, you can see less points are being generated. So also the feature scale, we can set it to large or to normal. So if you just have a quite easy to track shot, like a wide landscape, you can set it to large because the tracking will go faster and will be more accurate, because it won't be distorted by kind of small things that would normally distort such a track. So because we're having not really much recognition points, I don't want to set the sensitivity low, which I would normally do, which increases the accuracy of the shot. So I would just let it right here, and then yeah, this is pretty good. You can click fast tracking, but I'll just click start, and then it will start tracking. So you can see it goes quite fast. It goes almost real time. And what it obviously does is it is searching for points in the scene which it can recognize, and then every single frame after frame after frame. It is searching for that same point again, and then based on the movement of each of those points, it calculates the movement of the camera. I mean, I have serious respect for the dudes who created this program. Holy crap. I mean, this is just almost scientific. But it has been a revolutionary program in the motion tracking industry, which is just amazing. You can even see when it is expecting to finish. It is now, well, it's this minute, so it will take excuse me, less than a minute to track. This is quite good because you can kind of analyze it by eye. The more appropriate tracks you see, the more tracks it has generated, so the more accurate everything will be. However, of course, there is always a but or however or something like that. There are some things which we can do to improve the shot, like deleting these. But unfortunately, every shot or every frame, these things are being regenerated. So obviously, when you have one of these things, look right here, this little guy right here is completely miscalculating the movement. So we'll have to delete that in order to get a cleaner track. So normally it doesn't take really long, but for now I'm just gonna leave it because I know it will turn out right. So as we go into the 3D perspective, what we can see is nothing. We're just having a grid. So I mean, how's that possible? We have tracked the features, right? No. I mean, yes, we have tracked the features, but what we need to do now is out of this two-dimensional data, because it is now still two-dimensional, we actually need to generate a camera solve. And what we can do is go to camera solve, and we can just hit the start button. But before we do that, we want to optimize radial distortion parameters. So when you have a very smooth dolly shot, what you can do is you can optimize the path, the camera path smoothness. But in a lot of cases you don't, because it just optimizes the smoothness, but it also will erase some of the data. I mean, you know, that's pretty obvious. So let's just click start. And you can see what it calculates now. But it goes pretty fast. It is already on, you know, 40% right now, already 50%. So again, you can see when it's ready. 411 is now 410. So it's now accessing the radial solve for the free move, which means that it is now actually bringing all the points together, and it is trying to move them into spatial space. That's not really a correct sentence, but anyway. Ta-da! Here it is. These points are always the points you want to be looking for in Buju, because these points are the 3D generated points. And as you can see, they actually pretty much stay on place. Right here, which means that the tracking has gone really well. And now as we go into the 3D view, we can actually see the points. And even better, we can see the camera move, and we can see that it is pretty smooth. So, you know, I'm always amazed about this, because, you know, you can just see how you actually moved on the set. You can see, you know, how you bend the camera, and, you know, it's just so amazing. But even a more amazing thing is, as I go back into 2D, and I select the tree right there, I can actually see where the tree is in space. You know, so the tree is about right there. So I mean, this is just pure awesomeness, isn't it? But when I select one of these, well, let's just select those, you can see they are much closer to the camera. They are actually here. So that means that the distance from here to the tree should be really much, but as we go to the shot, we can see that the trees do have a really great distance. in comparison with this one to the camera. So it's just so accurate, and it's just amazing. So there's a few things we can do now. As we go to 3D task, we can actually go to lens distortion automatically, and we can add a test object. I didn't know if you, yeah, like that. Okay, so the test object actually moves along with the scene, and this is it. And you can also see that automatically you can see the edges here, which means that it has calculated the lens distortion, which is awesome because you can now see that these lines are straight, and as we look at the original footage, these lines are not straight. So it has just, deleted the lens distortion, which is also an awesome thing. And you can even see the object here in 3D, where you have placed it. You can move it, you can whatever. So there's a lot of options like importing object models. If you select these points, you can even create a mesh. You can add locators, but those are kind of more advanced stuff, so we'll not really be going into that. But this is just the basics of motion tracking. And what we need to do now is export the camera. And you can see that Bushi just has so many exports, including 3D Studio Max, After Effects, Cinema 4D, Combustion, Houdini, Maya, and then text. And if we want to export it for Nuke, we have to export it as a text, because then later on we can import it with the script. So for now, this was pretty much it. This was pretty much the first part of the compositing kind of tutorial on CG Test Plus. On the second day, we're going to import this data into Maya, and we're just going to add an object. And then in the third day, what we're going to do is we're going to import this data into Nuke, and we'll add some quite exciting stuff. Okay, well, this was pretty much it. Thanks for watching. I'm Yuko Trump for CG Test Plus, and I'll see you next time.